Okay, I'm gonna be going over a few formulas that we've seen so far. I'm gonna start with the amount of energy transfer or the amount of heat transfer. And we've seen that that's equal to Q equals mc delta T, where delta T is just the change in temperature. Lowercase c, that's just the specific heat of that particular material. And obviously where m is just the mass, okay? And then we also have seen density, which is equal to the mass over volume, okay? Where again, this is mass and this is volume. I do forget to mention that the unit for Q is going to be in joules, and for this one is going to be kilograms divided by meters cubed. Now, we also have the rate of energy transfer. So not only the amount of energy transfer or the amount of heat transfer, but also the rate of it. And we use that as Q dot is equal to Q over delta T. So in this case, we're actually introducing time, okay? And units for this is going to be joules per second or watts. But for watts, we just use W. So in this case, this is just the amount of heat transfer, and this is just time, okay? We've also seen this other equation, which is heat flux, which is lower Q, which is defined as the rate of energy transfer over area. And units for this is going to be watt over meter square, okay? Where again, Q dot is just the rate of heat transfer. And this is just the area. And again, that's just heat flux. We've also seen conduction, which is also Q dot, but in this case, we need to take into account the thermal conductivity, which is thermal conductivity. Times the area times the change in temperature all over the thickness of that particular material, okay? Again, that's thickness. And this is fourth formula, and then I'm just gonna put it over here. So the fifth one is convection. Formula for that, it's Q dot is equal to H times the area and the change in temperature, which is in this case gonna be the temperature of the surface minus the temperature of the let's just say ambient temperature, which is, you know, far away enough from that temperature of the surface. And as we know, unit for this is going to be still in watts. And of course, we can't forget the other one that we've seen, which is mass flow rate, which is Q dot is equal to m dot C delta T. where the mass flow rate is just equal to the density times the speed velocity um, times the area. Okay, it could be the surface area as well. It all depends. And of course, our units for this one will always be watts, and for this one is going to be kilograms per second. Okay, so that's everything we've seen so far.